All right, so welcome, math students. This is the first of our flipped lessons. Now, the first few weeks may be content you've done before, might have even been in grade 7, might have even grade 8, but I need to get a foundation so we can build on that moving forward in the term, and it's a nice, easy way to start the year as well. So the first thing we need to do is just make sure you understand the different parts of an expression or an equation, and then we're going to play around with them later. So the first thing that we're going to look at is this thing up the top here. All right, so that is at the moment that's sitting there, that's an expression, and we just want to talk about the different parts of it. All right, so the first thing we need to look at is what the coefficient is. And the coefficient is, it's that number in front of the letter, okay? So it's, it is the number in front of the letter. So in this case, the examples here would be the numbers in front of any letter there. So the letters there are the x squared, the x and the 8. So those numbers are going to be 3, 2, and -8. Now these are really important. We don't write the plus there. We don't put the +3 and the +2, but they're always implied. So whatever's in front of that number, that's what's going with that coefficient, if you like. So I always think about it in a car. If you're driving along in a car, you don't care about what's going on behind you. Okay, you care about what's in front of you. Just like any number, it cares about what's in front of it. It's really important, okay? This 15 over here, that we'll get to in a minute, it's not 15, it's -15, okay? So it's really important, okay? So the constant that I spoke about there, that is the number without the letter. So it is number without a letter. Oops, sorry about my writing there, getting used to the iPad. So in that case, the example is going to be -15. The pronumerals are just as simple as the letter, okay? So in that case, the pronumerals are going to be x and y, okay? Even though x is squared, the pronumeral is still the x letter there, all right? The term, this is just a combination of the pronumeral and the coefficient, really. So it's just a combination of the numbers and the letters. All right, so in that case, it's just going to be 3x squared, it's going to be 2x, and again, the -8y, okay? Another term would be the -15 in there. It's still a term, it's still a bit contentious, that one. Some teachers will say, yes, it's a term, some say it's not. It doesn't really matter too much, but I'd like to say it's still a term, all right? An expression, this one is just a combination of terms. It's like a stepping up from there. So we just have combination of terms, okay? So in this case, it's just going to be that whole thing. So I've got 3x squared plus 2x minus 8y minus 15. That whole thing is what we'd call an expression, okay? So an equation is just two expressions that are separated by an equal sign, okay? And I'll get into later on in the year that you only ever put one equal sign in a line, okay? So when we do some examples, I'll get into that, okay? So it's two expressions separated by an equal sign, okay? So an example, it's a bit harder to do that because that was just an expression, but we could say 3x squared plus 2x minus 8y equals 15. Okay, so now that's no longer just an expression. it is an equation because I've got that equal sign in there and I've got two things that are balancing, okay? If I have a look at these examples here, I'll try and highlight what I'm going to do here. I want to look at the coefficient, so I'm going to do I'm going to color in the coefficients in yellow. So the coefficient of this expression down here is the 4, and it's positive 3. In this one, it's going to be the 12, the positive 2, and the 4 there, okay? If I choose another color, so if I want to do the constants would be positive 12, that would be 8, and that would be positive 8, okay? So if I then start looking at what is the pronumeral of this one, yeah, I could still color these in. Pronumeral, it would be the x here, it would be the xy there, the x, the y, and the x there, and I use x and y probably too many times, but you'll get used to that. If I look for a term, okay, so I'm looking at a term, I've got one term here, I've got another term here, and the 12 we could call it a term, but I'm going to leave that for now. Got the 12x there, got the positive 2y there, and I've got the 4x there, okay? If I now look for my, oops. Oh, I don't want to do the same color. Let's choose. The expression would be this whole thing there, okay? As it would be with this one, and we could argue that the 2x there is still an expression, but now it's actually become an equation. We could do, so this equation one would be this whole thing here. Okay, it's a bit messy, but try and understand that the equation is the whole thing, and the expression is kind of just part of it, okay? So there are the reasons why we use that terminology, which we'll get into a little bit later on. All right, so let's start simplifying expressions. Now remember, expression doesn't have an equal sign, so all we're doing is trying to simplify an expression here, all right? So the first thing we want to do, if we want to add and subtract terms within an expression, they must be like terms, okay? And what I mean by that is the pronumeral after any number that you've got there has to be exactly the same, okay? So they must be like terms, all right? So what I mean by that is if I've got 3x plus 2y, I can say that they are the same. And what I like to do actually at the start is say, okay, oops, let's try that again. I'll get rid of that. 3x plus 2x, because now they're like terms. They weren't like terms before, and now if they're like terms, it's kind of like, and I encourage students that struggle with this part to highlight them. Certainly, absolutely, if you've got coloured pencils and you want to know whether they're like terms, and they need to be exactly the same. Once I know they're the same, now I just do whatever the case is with those numbers at the front. So the 3 plus a 2, I'm going to end up with 5x. Okay, that's that easy. All right, another example might be if I've got 8y minus 3y, are they the same terms? Are they the same, pronumerals? So once I know that they're the pronumerals, I've coloured in that they're exactly the same, I can now do the 8, and that's a negative 3, so it's going to be 5y, okay? One last one that I like to do is if I've got something like 3x plus 2y, how do I simplify that expression? And the answer is there's nothing I can do. That is as simple as it can get. It's like saying there are 3 x-ray machines and I want to add 2 yellow bananas. I don't know what y is going to be. There's nothing, I can't add those two things together to get one particular thing, all right, when I'm adding and subtracting them. All right, so that's really important. Might just try do one more example down here. If I have something like 4x squared plus 3x plus 2x plus 4y minus a y. If I wanted to simplify that expression, first of all, I've got to highlight the things that are common. I've got an x here, I've got an x here. What else have I got? Got a y, a negative y, and a y. The x squared, it doesn't have something that's exactly the same. So I can't actually add, subtract, or do anything with that. Okay, so it's still going to sit out the front. It's going to be 4x squared. I've got those x's that are the same, so I can add them together. So I become 5x, okay? I've got 4 lots of y. Now that I know that they're the same, I don't even think about them. I just say 4 minus 1, because there's always an actual 1 written in front of it when it's not there, and then that's going to give me 3y, and then I'm finished. All right? So, multiplying, dividing terms, a little bit trickier, but not really too much. Similar things. So they don't need to be like terms, okay? So they do not need to be like terms, all right? But there are things that we're going to do. So we could say 3 times a, I'm just going to say, I can't add the number 3 and an apple. So what I can do is I can sort of join them together, if you like, okay? So what we do is we just write 3a, okay? Then if I've got something like 4 apples and 3 bananas, what I can do is, and again in maths, whenever you can do something, do it. Can I multiply a 4 and an apple? No, I can't. Can I multiply a 4 and a 3? Yes, I can. So I should do that at all times. And then the a and the b are just going to be multiplied together, just sort of squashed together, if you like. Okay. Another example of that would be 4x. Ooh, I don't like using x with this because let's do a p, because my times is going to look a little bit different until you get used to what my x's are. PQ. So again, whenever I can do something, I'm going to do it, and I've got 4 times 8 and give me 32, and I've got p squared because I'm going to raise it up. Okay, so hopefully you've done a little bit of that in the past. I've got p times p, I've got p squared. Okay, and that should be enough of those. Dividing terms. Okay, so this is where hopefully you've done a good solid foundation. I believe fractions is such an important part of mathematics that you would have spent hopefully some time on. If you need some work and some videos on that, I'm happy to provide individual, but you'll have to approach me and I'll make something up for you, okay? So when we come to dividing expressions, let's start with 12x squared divided by 4x. I like to treat this as a fraction. Okay, there are lots of different ways to do it. I find this is the easiest way. I was going to do both versions. I think this is the better one, so I'd rather you just do this way, to be honest. And I'm going to start my process. I always work down the page. If I wanted to, I could have put an equal sign next to it and done one version there and then followed it down, but I kind of just like starting it, working down the page. I would then encourage you to make it a fraction. Divided by means a fraction, okay? So I would do 12x squared divided by 4x. And then I just look for common factors between the top and the bottom, which is what you would have been doing since hopefully grade 2, 3, I'm not sure when you would have learnt this, but I am going to now look for common factors between the two, and between the 12 and the 4, I know a common factor would be 4, so I say how many 4s are in 4? 1. How many 4s are in 12? There are 3, all right? Are there any common factors between x squared and x? Yes, there is. X is it, so I'm going to cross out 1 and cross out the other one. So I'm left with whatever I've got left. I've got 1x on the top and I've got 1 on the bottom. So then I just simplify that to 3x, okay? Back to this part here, I could have thought about this as 12x times x, and that looks a bit confusing in there. Hopefully you're not thrown off by that too much. And if I look at that, and I might actually change the color of my multiplication sign, so it's times in there. So then I've got 12 if you want 12 times x. Now I could look for common factors between the two, and I can say, okay, there's one there and there's one there. And that may be a better way for you to think about that, raising that power to 2. All right. All right, that should do for that. I just ask them. I'll put some questions on MathSpace, work through those. If you want it, if you do that in 5 minutes, you want something to do, look at the extension activities within those lesson outlines. They'll always be there. They're not compulsory. They're just a bit of fun. Okay. I hope that helps.